So we are going to just set up our first example here. What we're going to do is we are going to split it into two parts. The reason being, to the left of where that is, where that red line is, it's just an area under a curve, and to the right of where that red line is, it's an area between two curves. So we have two slightly different setups for those. So to the left, we have that y equals x plus 1 to the 1/5. So we're going to do an integral in terms of x from -1 to 0 of just that function. And will be dx. And then we're going to add on an integral that finds the area between those two curves. Our left-hand equation, we could easily get in terms of either variable. Right now we're in terms of x. We could switch it and get it in terms of y pretty easily. Our right-hand equation there, we really only can do it in terms of y, because it would be hard to get y alone. So we're going to have to do a dy for this integral, meaning we're going to have to do right minus left. So let's, over in this equation, let's raise both sides to the 5th. We'll get y to the 5th equals x plus 1. And then subtracting 1 over, we get y to the 5th minus 1 equals x. So we'll do our right-hand function minus our left-hand function. So we're going to have negative y squared plus 3y minus, and we want to do parentheses because we have two parts, y to the 5th plus, y to the 5th minus 1. Now our integral values should be y values. We'll start at 0, y value of 0, and then we would have to set these equal to each other and see where they intersect. Let's just call it b for now. Okay, because all we're going to do is we're just going to do this setup here, just so you can see roughly the idea of what you would have to do. Okay, we're not going to actually go through and solve this. But again, you would just set them equal to each other, and then you would have to find what b is. For our next example, we're going to find our area between negative sine x and negative 2 sine x from 0 to pi. So we'll sketch a graph. So negative sine x goes down first and looks something like that. Negative 2 sine x does the same but goes down to negative 2. So we are finding this area right here. Well, when you're finding an area in between, you just do the integral of top minus bottom. So we'll do the integral from 0 to pi of negative sine x, because it's the top, minus negative 2 sine x dx. So we can neaten that up. We're going from 0 to pi. We'll have sine x dx when we add those together, because it's really negative sine x plus 2 sine x. We'll take our antiderivative, which would be negative cos x. We're going to evaluate it from 0 to pi. So we'll have negative cos pi minus the negative cos 0, so this will really become plus. Cos of pi is negative 1, so minus the negative 1 is 1. Plus cos of 0, which is 1, we get 2. Which is kind of interesting that the area in between minus 2 sine x and minus sine x is really just 2 from 0 to pi. On this slide, we're just going to talk about how you would attack a problem like this if we wanted to find that area. Let's say we called this equation of a line g of x, and this equation of a line we'd call h of x. What we would have to do is we'd have to split it down the middle, and left of that line, our top would be f, our bottom would be g. But then right of that line, our top would be f and our bottom would be h. So we would first do an integral from 0 to, it looks like 1.5 of f of x minus g of x. And then we would have to add on an integral from 1.5 to 3, it looks like, of f of x minus h of x. And each of these are in terms of x, so we would have a dx at the end. And then you would go ahead and you do the antiderivative, do your integral of each, and then find your area. Okay, but that's our general strategy of what we're going to do. And we're going to use that in our next problem. So we're going to find the area of a triangle that has these three vertices. So we've got 0, 5. So we'll be plotting 0, 5. We'll have 2, negative 2, and 5, 1. That's 0, 5, 5, 1, and 2, negative 2. And what we have to do is we have to find the equation of each of those. So let's maybe start with the green one. We know our y-intercept is 5, and we're going down 4 and right 5. So that would be y equals minus 4/5 x, and then y-intercept is 5. So that's our green equation there. The red one will probably be the next easiest because we also have y-intercept of 5 we know. And we're just going, this time it looks like we're going down 7 and over 2. So we'll have y equals minus halves x plus 5 for that y-intercept and for that red line. And for the blue one, we have a slope of 1. And if you kind of trace it back to the y-intercept, we are hitting at negative 4. So our blue one will be y equals x minus 4. So we're going to use the strategy we just talked about a second ago. We'll split it into two parts. Left of that dotted line, we have green. We're going to have green minus red. Right of it, we'll have green minus blue. So we're going to have an integral from 0 to 2. We'll have our green function, which is minus 4/5 x plus 5, minus our red function, and we'll stick it in parentheses because it's got two parts, minus 7/2 x plus 5, and then will be dx. And then what we'll do is we'll add on our integral from 2 to 5, and that will be our green minus our blue now. So the green again is negative plus 5, and we'll subtract off our blue in parentheses, which was x minus 4. And we are dx again. So in that top one, if we neaten it up, we'll be 0 to 2. We'll have a 5 minus a 5, really, so that's gone. And we'll really have negative 4/5 x plus 7/2. So that's really negative 8/10 plus 35/10, which will give us 27/10 x. And then we'll add on our integral from 2 to 5. Negative 4/5 minus 1x will give us negative 9/5 x. And then 5 minus a negative 4 is really a plus 4, so we'll have plus 9 dx. So we'll take our antiderivative. We'll have x squared multiply the front by a half, so we'll have 27 over 20, which is going to get evaluated from 0 to 2. We'll add on. We're going to have x squared minus 9/10 now. and we'll have plus 9x, and that's going to get evaluated from 2 to 5. So we'll have 27 over 20 times 4, really, because that's 2 squared. 27 over 20 times 0, plus, we'll have negative 9/10 times 25, plus 45, because that's 9 times 5. And then we'll have minus, we'll have negative 9/10 times 4, because that's 2 squared, plus 18. And if you punch that in, you will end up getting either 13.5 or 27 over 2. So one last example. Say we want to find the area between these two curves. When you graph it, the picture looks like this. Notice they intersect once at 0, 0. And they intersect again at a point that's not nice. Well, you could find that on your calculator by doing an intersection, and we're just going to do it to the nearest hundredth. So we'll get 1.18. So we're going to have our top minus our bottom. So that's going to be the integral from 0 to 1.18 of x over the square root of x squared plus 1 minus our bottom, x to the 4th minus x dx. Well, that first part we're going to need a u. So we're going to split this up separately. We'll do 0 to 1.18 of x over square root of x squared plus 1 minus, then we'll do the integral of 0.8 of x to the 4th. And because this negative will distribute to that negative, this is really going to end up at plus. I need my dx's here. Plus the integral from 0 to 1.18 of x dx. So this left one is going to be the tricky one. We've got to use u substitution. We'll let u equal x squared plus 1, meaning that du is just 2x. Well, we have 2x dx, sorry. We have to get x dx. We'll have 1/2 du equals x dx. So we'll do integral from 0 to 1.18. We'll have 1/2 u to the minus 1/2, because we really had a square root of u on the bottom, and then du. Well, this will become u to the positive 1/2. When you divide by a half, it's like multiplying by 2. So 2 times a half, that wipes out. And then when we sub our u back in, we'll have x squared plus 1 to the 1/2 that needs to be evaluated from 0 to 1.18. Then we're going to have minus. The antiderivative of x to the 4th is 1/5 x to the 5th, which we need to evaluate also from 0 to 1.18. And then we'll add on 1/2 x squared, which needs to be evaluated from 0 to 1.18. So essentially now, the whole thing's just being evaluated from 0 to 1.18. Well, when we sub in 1.18, this is going to end up as 2.3924 to the 1/2 minus 1 to the 1/2 minus 1/5, 1.18 to the 5th minus 0 plus 1/2, 1.18 to the 2nd minus, that would end up being 0. And when you type that all in, you end up getting 0.7853869,526. And because we rounded that value, our b value in our integral, This is essentially an approximate area because it's not the exact value of the area because we did that little bit of rounding. That's all for this video. We'll see you next class, period.